Alright, so today is day 141 for Algebra 2. We're going to talk about the Pythagorean Identity. So, you're going to talk about this more in advanced math identities. Basically, like, identities are, we can replace one thing for another really quickly. So, the identity, let's say I was like, all my threes. In each group, raise your hand. All my threes, raise your hand. Threes, your identity is a 3. Even though you also have your own name, right? Or I could say, what can E16 raise their hand? Who's E16? Aaron's E16, right? So Aaron's identity is Aaron, that's who she is, but her identity is also E16, okay? So the identity is important because we could use it to find missing values, okay? And it all comes back to the Pythagorean theorem. So let's go talk about Pythagorean theorem in your groups. Remind them, what's Pythagorean theorem? Why would you use it? When would you use it? And then we'll bring it back together. I'll give you about 20 seconds, okay? Ready, go. Okay, so Pythagorean theorem. When can we use a Pythagorean theorem? On what specifically? A right triangle, that's correct. Okay. Right? Can we use it on any triangle? No, we can't use it on any triangle, but we can use it on a right triangle. And we know it has to be a right triangle. And what is the formula for Pythagorean theorem?
A squared plus B squared.
Good, right? And we have two legs, and our C is always the hypotenuse, right? Okay, cool. So we could use that for what we're going to do today. So it's related. Let's have you, actually we'll go here. So notice that the Pythagorean identity, you see how it says sine of theta squared plus cosine of theta squared is equal to 1. Y'all see that?
Yeah.
Okay. Sine of theta squared could be like, didn't we say sine of theta, isn't that our y? Isn't sine always y, the y value? And isn't cosine always the x value? Right? So we could say that y squared plus x squared is equal to 1, right? So that's where that is derived from. But let me show you one more way, okay? And I'll come back to this slide. Actually, why don't you, I'll pause the video here and write these down, and then we'll build upon this some more. All right, did you all write this down? Okay, so look at the unit circle, okay? Unit circle, we can make any triangle at any point at the unit circle, right? Let's say we have a triangle right here. We have a hypotenuse of 1. So I could say that this bottom part's a side, this part's a side, and this is my hypotenuse, right? Hypotenuse is 1. What is the rise? What value is the rise? X or Y? It's not a trick question. It's the Y, right? And this is your X, right? Does that make sense? Okay, cool. You see all the points in a circle? Let me connect it one more time for you. Remember conics? What's the equation of a circle for a conic section? Remember the circle project you did? Think about H and K. Vector group really quick. What's the equation for a circle? Conic sections. Okay, well, who wants to take a shot at it? Maybe it's in your notes. Okay, remember this. X minus h squared plus y minus k squared is equal to r squared, right? What's r always equal to? The radius. What's our radius always in all of our unit circles? 1, right? What's our center of our circle here? 0, 0, right? So what's x minus 0? X squared, right? What's y minus k, or y minus 0 squared? Y squared, right? Isn't that what we had earlier? But we also know that y is our sine and x is our cosine, right? So this is where we get the Pythagorean identity, right? Do you all see how that all connects? Okay, so you need to know the concept of where it comes from. I'm going to do a couple problems for you, and then we're going to do a couple more together, and then we'll be done, okay? So this is one way your problems could come about. The Pythagorean identity comes about in different types of problems that I'm going to show you one way of problems, okay? And one of the big ideas is to think about, you want to think about at what part of the circle or unit circle you're talking about. So how many degrees is the end here? When we start, how many degrees is it? 0 or 360. So from 0 to 90 degrees, what quadrant is 0 to 90 degrees? First quadrant, right? What's the x value in the first quadrant and the y value? Always.
0, 0. 1, 0.
Are they positive or negative? Can x be negative in the first quadrant?
No.
Can x be negative, or can y be negative in the first quadrant? No. Okay, good. So it goes 90, 180, and so forth. Okay, so think about that. We'll come back to that in a moment. Okay, it says find the cosine of theta given sine of theta is equal to 4/5. And it says 0, our theta has to be between 0 and 90, okay? So the first thing we want to do is start with the Pythagorean identity. Alright? So what information do they give us? They say, hey, look, sine of theta is 4/5. So watch me. I'm going to replace this. I want to figure out what's cosine of theta. We don't know this yet, okay? So sine of theta is 4/5. I'm going to put 4/5 into here. Okay? And it's supposed to be squared, right? Sine of theta, we're replacing with 4/5, but we still want to keep the squared. Plus cosine of theta squared is equal to 1, okay? So what's 4/5 squared? What's 4 squared? 16. 5 squared? 25. Plus cosine of theta squared, right? And we want to get the cosine of theta squared by itself. So I'm going to subtract 16/25 on both sides. So we got cosine of theta squared. And 1 minus the fraction of 16 over 25 is actually 9 over 25, right? Does that make sense? Simple fraction problem. Who needs me to show you the fraction problem? Okay, so fraction problem 1 minus 16 over 25. How do you make 1 a fraction, everyone? Over 1. What's a common denominator for both of these? 25, right? So this could become 25, right? And this one's also 25. But we don't have to change the second fraction. We're going to keep it the same. 1 times what is 25? 25. So 1 times 25 has to be 25. Right? And 25 minus 16 is equal to 9. Right? Keep the denominator 25. Does that make sense? Okay, do we need to do all that side work to do this problem? No. Okay, cool. So now I'm going to... I noticed that the cosine theta here, back to our original work right here. Cosine of theta here. Did you notice that it is being squared? What's the opposite of squaring something? Square root, right? So I'm going to square root both sides, okay? And I'll get cosine of theta is equal to, sorry, it's a little bit here, plus or minus rad 3 over 5, right? Let me fix this a little bit. I'm going to erase the side problem. Okay? Is equal to plus or minus rad 3 over 5, right? Because the square root of anything has two answers. It has a positive answer and a negative answer. Square root of 9 is 3. Square root of 25 is 5, right? Does that make sense so far? Okay, cool. But remember, we're talking about cosine. What value is cosine? Is it our x or our y on the unit circle? X, right? So thinking in the first quadrant, you see how it's between 0 and 90 degrees? First quadrant, quadrant 1. Can x ever be negative? No. So even though I'm getting a negative answer, do I include it? No. So the true answer is the cosine of theta for this one is going to be positive 3 over 5. And then we're done. Okay? Yes, sir?
So you'll take both answers or just the positive one?
Just the positive one, right? Because conceptually, can we have a negative cosine in quadrant 1? No. Can we? No. Nope, we can't. Okay? Does that make sense? Let me do it one more time on number 2. I'll go a little more quickly. You'll see this 8/17 here on number 2. Looks kind of scary. Not to worry, you're just going to do the same steps, okay? So we find the cosine of theta given sine of theta is equal to 8/17, and we're looking at the degrees from 0 to 90 degrees for theta, okay? So again, I'm starting with my sine of theta, or I'm sorry, my Pythagorean identity. Okay, and we're replacing sine of theta with 8/17 and rewriting the rest of the problem out, right? Okay, and I know that 8 squared is 64, and 17 squared is 289. I got cosine of theta squared is equal to 1, right? Now, couldn't I have skipped this step right here? Couldn't you have skipped this step on your paper? Yeah, we could do that, right? All right, so now I'm going to subtract 64 over 289, okay, from both sides. Now I got a question for you. How do we make 1 a fraction? Over 1. What's the common denominator between both of these? 289. So it's like saying, what's 289 minus 64? What's 289 minus 64?
220.
Good, 225, right? So we got cosine of theta squared is equal to 225 over 289. Take the square root of both sides. And when I do that, I should get two answers, right? Positive and negative, 15 over 17. Now, look at what it's saying. We're trying to find the theta that's between 0 and 90 degrees. So it's in the first quadrant, right? So can I have a cosine? Can I have a cosine that's negative in the first quadrant? No. So my true answer is going to be cosine of theta is positive 15 over 17, okay? Give me your phone, or whatever you're doing. So number 3, right? Find the sine of theta, okay? So numbers 1 and 2 was cosine, right? Cool, so let's start this off. So we want to find the sine of theta, given cosine of theta is equal to 5/13. And we want to know what theta is when it's between 0 and 90 degrees. So 0 and 90 degrees is which quadrant, everyone? 0 and 90. First, right? Make them easy today, right? But if it was a different quadrant, then you have to think about it, okay? Here we go. So find sine of theta. Here we go. So number 3, we're going to start with always start with the Pythagorean identity. We're doing this one together, by the way, so write this down as I go. Okay? Make sure we're all working, then we'll have extra time later to work on our AMs, okay?
I like AMs.
I know, no one likes homework. Just gotta do it. Okay. So what information do we know here?
What cosine of theta is?
Good. Cosine of theta is what, everyone?
5/13.
Good. What information is missing?
Sine of theta.
Okay, good. Sine of theta. So we're going to replace cosine of theta. Now watch this. Couldn't I just write cosine of theta and rewrite it as 5/13, just squared right there, right? And cosine and sine of theta will just bring this down. Is equal to 1, right? What's 5 squared?
25.
13 squared? 169. Good. And then we're going to bring the rest of the problem down. Oh, man. I just messed that up. Sorry about that. Let me fix that. Okay. Okay, now I got a question. When I subtract 25 169ths on both sides, what's 1 minus 25 169ths? Okay, how do we make 1 a fraction?
144 over 168.
How do you make 1 a fraction? Good. So and then we convert that. It's going to be 169 over 169, right? What's 169 minus 25? 100 and what? 144. Okay. How do I get the square off the sine of theta? Square root it, right? So when we do that, we get two answers, a positive and a negative one, right? So which one are we going to focus on? Positive, right? Because we know sine has to be positive at 0 to 90 degrees. Okay? Okay? Next one. Now look at number 4. What's different about number 4? What's it saying? Find what?
Tan of theta.
Tan of theta, right? Okay. Well, let's tangent. Let's go back to our paper. We know sine is what? Y or x? Sine is what? Y. Cosine is what? Okay, tangent is what? Y over x, right? Over here it says given cosine, right? Does it give us a sine though? No. So we know cosine. We know this is our x. How do we figure out our sine? We just use the Pythagorean identity. So this one's going to take an extra step, okay? So we're going to do what we did before. We're going to try to figure out sine of theta over cosine of theta, but we have to figure out what sine of theta is. So we have to plug it into our Pythagorean identity, okay? What information do we know?
Cosine of theta.
Okay, what's cosine of theta, everyone? Okay, good. So when I put this down, I got a question for you. What's rad 3 over 2 squared? Let's skip a step. Why don't we learn how to do that a little bit better? What's rad 3 squared?
3.
3, good. What's 2 squared?
4.
Good. So what's rad 3 over 2 squared?
3 over 4.
Good, 3 over 4. Excellent. Okay, you all writing this down as I go? And we're bringing the rest of the problem down. Okay, now, we have to subtract 3/4 on both sides. Let's see if you can get this. What's 1 minus 3/4? Good, 1/4. Excellent. I'm really glad you did that. Otherwise, I would have assigned another AM. No, I wouldn't do that. Okay, how do you get the sine of theta by itself? What do you do to both sides?
Square root.
Good, square root. Now, what kind of answer should I have here? Which quadrant are we focusing on here? First quadrant still, okay? Still making the problems easier, but you should still think about that. And your answer is going to be, what's the square root of 1/4? 1/2, right? Cool, but is that what the question's asking? No, what's it asking for? Tangent, right? So tangent is going to be, we said, is sine of theta over cosine of theta. So now we have to put those in, right? We know sine is 1/2 divided by rad 3 over 2. Uh-oh, it's a division with fractions. How do you divide fractions? Turn to your neighbor really quick. How do you divide fractions? Okay, cool. So we're really going to do what's 1/2 times rad, or 2 over rad 3. Okay? Right? So when I look up here, is there anything I could simplify?
Maybe the 2's.
The 2's, okay. Maybe? No, I think we can. Okay, so it's going to be 1 over rad 3, which is an answer, right? But what's wrong with the answer? Good, so we need to rationalize our denominator. When we do that, we get rad 3 over 3 is our answer, okay? That's the tangent of theta, okay? Does that make sense?
Yes.
Awesome. All right. So that concludes the lesson.